Today I'm going to talk to you about how we find the equation of a trig graph. Any trig function is a periodic function, and as you can see in front of us we have a periodic function. We can see that because it's repeating itself. So let's have a look at what we've got. The maximum point on this graph is at 10 and the most minimum point at this graph is at minus 10. Now that means our amplitude is going to be 10. We can have a look that the x-axis is our equilibrium position. That means that it's the halfway mark between the maximum and the minimum. So therefore the graph has not shifted up or down, so the value of d is going to be 0. So I'm going to write that. D equals 0. Now I'm also going to write that a equals 10 because we've established that the amplitude is 10. Now let's have a look at the type of trig function we're going to use. Well, because here's our y-axis and the graph appears to begin at the amplitude, goes down and up, I'm going to model it using the cosine function. So in a moment, over on the right, I'm going to write down the basic cosine relationship that we've been using. Okay, so there we have the function that we've been using. Now I can already place in a is 10 in there, and I can also put d is 0 in there, but let's just go back. Actually I can see enough of the graph on the screen. So what we want to do is we want to focus on what's the period of this graph. Well, remember the period is just one cycle from the same point on each point on the graph. So we can see here that it goes from here up to here. Now looking at this, we can see that this is going up in half pies. We can see the period of this graph is 4 pi. So in order for me to work out the equation, I need to find the value of b. So don't forget the equation for the period is 2 pi divided by b. So if I place in 4 pi equals 2 pi over b and rearrange that equation, I get b equals 2 pi over 4 pi. The pi's cancel, and 2 over 4 can cancel down to be 1/2. So the value of b is 1/2. Now you have to also decide whether there's been a horizontal shift. Well, no, there hasn't in this case because I've chosen to use the cos function, so there has been no horizontal shift. So therefore I can now write the equation of this graph as y equals 10 cos 1/2 x. Alright, now so I'm going to move on to a second example. So in front of you, you can see there's a graph. It's a periodic function as it's repeating itself. Now I've got to make the decision on whether I'm going to model it using sine or cosine first of all. Now if I look at sine, well remember sine begins at 0, 0. Well if I look here, this graph, if I'm choosing from the same point, is beginning at 0.25 pi, which is 1/4 pi. So if I'm going to model it using the sine function, I'm going to have to include that horizontal shift of 1/4 or pi upon 4. Let's have a look at other things. I could model it using cosine if I feel like it. If I was to model using cosine, then I'd have to start from the point that begins at the amplitude, which would be here, which would give you a 3 pi upon 4 shift. Now, I don't have to model it like that. There are so many options I could choose. I could choose to model it via a negative cosine beginning here. I could choose to model it via a negative sine beginning here. Lots of options. You just have to pick which one you're going to go with. So I'm going to go with my original choice. I'm going to go with sine. So I'm going to model it. So first thing I'm going to do is write down the basic sine function that I'm going to be using. So let me just write that down. Then I have to write down what's the value of a, b, c and d. So let's go back to the graph. I'm choosing sine, and I've just already said as it's shifted from this point to this point, it's moved in this direction. So therefore it's going to be minus pi upon 4 because remember it goes in the opposite direction. So c is going to be minus pi upon 4. Well, I'm going to put minus pi upon 4 into there. Alright, let's have a look at the amplitude. So the amplitude, remember, is the maximum to the minimum, and obviously we need to find the equilibrium position. Well, the amplitude here is 2, or the maximum point is 2, and the minimum point is minus 2. That means the amplitude is 2, and the equilibrium position is the x-axis. So therefore, the graph has not shifted vertically up and down, so the value of d is 0, and we can say the amplitude is 2. Now let's have a look at the period. So remember, value of b affects the period. So what I have to do to work the period out, let's first of all have a look. So let's begin at this point here. This is where we're beginning our sine function here. So it's at 1/4 pi or 0.25 pi. We do one cycle and we get to 2.25 pi. That means the period is a full 2 pi units. So therefore the period is 2 pi, and therefore it's got the same period as a normal sine curve. So our value of b is just 1. So b is 1. So of course that's not going to really affect our equation. Now all I've got to do now is sub in these values that I found into my general equation, and that gives me y equals 2 sine x minus pi upon 4, and that's it.